On flight MB1, the shuttle climbs to an orbital altitude of 150 nautical miles for initial station assembly. Secured in its cargo bay are the components of the station's starboard transverse boom, including the basic subsystems that form a functional station and the support equipment needed to assemble it. Raising from its positioning mechanisms, the orbiter's RMS mounts the Flight Telerobotic Servicer, or FTS, to its end effector to assist in the assembly operations. A remote structural connection is then made, joining the node and the RCS tank farm, and a deployment device, similar to the Stabilized Payload Deployment System, or SPIDS, rotates these payloads outside the packaging envelope. This clears the way for the RMS and FTS to lift the palletized cargo and replace it in the aft end of the payload bay. Shifting cargo in this manner enables launching within the orbiter's payload CG envelope and assembling within the operational limitations of the RMS. Once the pallet is reinstalled and connected to orbiter power and water scavenging lines, the assembly fixture is remotely deployed. The two vertical rails of the fixture hold the station as it is built and allow completed sections to rise up out of the payload bay. The two platforms above either side of the payload bay function as workstations for EVA assembly operations. The FTS then retrieves truss strut containers from the top of the pallet and places them one by one at the forward end of both EVA work platforms. These worksite preparations are performed and controlled by IVA during the first 2 mission days on orbit. At the beginning of EVA-1, 2 astronauts secure themselves in foot restraints that slide fore and aft on the work platforms and receive the remaining 2 truss strut containers from the FTS for attachment to the aft end of their work platforms. The foot restraints, which additionally rotate and move toward the interior of the fixture, are actuated mechanisms which can be controlled by IVA or by the EVA astronauts. They provide the crewmen with the mobility needed to complete almost all assembly operations without leaving a foot restraint. The FTS also passes utility trays to the astronauts, who stow them on the truss assembly fixture for later installation. Rockwell's assembly fixture concept was demonstrated in a series of tests at JSC's Weightless Environment Training Facility. The experiment simulated the orbital construction of 2 bays of truss. The concept proved viable and generated recommendations for design improvements, which are now incorporated into the overall assembly process. Beginning at the aft end of the work platforms, the astronauts partially assemble the first space station truss bay. Next, they unfold and begin to install X pallets on either side of the partially constructed bay. These X pallets will hold the beta joints to which solar arrays will ultimately attach. The forward portion of Bay 1 is subsequently assembled. The first station bay is then indexed 5 meters up through the actuated assembly fixture rails. The crewmen complete the assembly of Bay 1. They then lower the structure half a bay's length in preparation for solar array installation. As with most other station components, the RMS and FTS act as the retrieval and positioning mechanism for the EVA astronauts. Here, the astronauts attach the beta joints and solar arrays to the X pallets with such assistance. Next, the assembly fixture moves the truss up so that the astronauts can begin to install the utility trays stowed on their work platforms. This deployable utility tray concept was also evaluated in JSC's WEDF in May 1987. The design, including clip mechanisms which attach the trays to the truss, proved viable and received favorable comments from EVA astronauts. Trays that extend between the beta joint and energy storage module are installed first. The truss is again raised and the astronauts assemble the third bay of truss and together attach another X pallet. The structure is then repositioned and the astronauts receive their utility distribution center from the RMS and FTS for temporary stowage on the work platforms. Using the FTS retrieval and positioning capabilities, the crewmen install the energy storage module on the X pallet. While continuing truss construction, the astronauts integrate utility tray installation into the assembly process. As shown here, trays which connect the beta drive and energy storage module are installed once the module is in place. Additional trays extend from the energy storage module to the position where the alpha joint will be installed. These the astronauts install while the RMS and FTS insert radiator fins into the energy storage module. The astronauts complete the third bay of truss and begin installation of the upper alpha joint transition struts. The RMS and FTS complete the radiator fin installation operations, while the crewmen finish the upper transition struts, working at the forward end of their work platforms. Assisting once again with a component installation, the RMS and FTS help the astronauts with the alpha joint installation and electrical tray connection by retrieving the unit from the payload bay and holding it in its final position. Deployable electrical trays, folded accordion fashion in the pallet, are lifted to the truss by the RMS and FTS. They unfold as the crewmen build the remaining truss bays. The astronauts install the remaining alpha joint transition struts and continue with the construction of truss bay 4, 5, and 6, indexing the truss 5 meters as each bay is built. Returning to the center of the 6th bay, the RMS and FTS temporarily hand an RCS module to an EVA crewman. With assistance from the RMS-FTS mechanism, the astronauts connect the RCS support structure to the truss. The S-band communications antenna is assembled to the station next, and the astronauts proceed with the construction of bays 7 and 8. An X pallet installed at the lower portion of bay 8 will support the utility distribution center. This item is retrieved by an astronaut from its stowage location on a work platform and installed by both crewmen. Connection of the deployable trays to the utility distribution center finishes the first phase of Flight 1 station assembly. At the beginning of EVA-2, the astronauts assemble the 9th bay of truss. After installing a second RCS module, the astronauts rotate a section of the electrical trays up to clear a path through the face of the truss at the forward end of the structure. Lowering the truss 1 meter more, the EVA crewmen begin to assemble a 10th bay of truss and attach another X pallet. Raising the truss 5 meters, they complete assembly of the bay and X pallet and lower the truss to work on the center of the bay. The RMS and FTS retrieve and position the RCS tank farm for EVA assembly through the area cleared by moving the electrical trays. They then return the trays to their original position. Connecting the trays to the tank farm, the astronauts temporarily rotate trays on their hinges once again. Moving the truss upwards, the astronauts assemble the 11th truss bay on Flight MB1 and another X pallet. With the RMS FTS assistance, they install the fluids module on this X pallet. As the FTS holds the stinger within reach of the EVA crewman, the RMS pulls the FTS and stinger out of the assembly area, permitting EVA installation of support struts. The crew supports this structure after assembly as the RMS and FTS re-grapple the assembly for installation on the truss. Lastly, the node is installed and EVA2 is complete. From within the orbiter, the crew deploy the solar arrays and rotate the station to its gravity gradient flight mode configuration. The station, including the assembly fixture which will serve the Flight MB2 assembly operations, is released from the orbiter and functions under its own power. In Flight MB2, the starboard transverse boom is grappled on the assembly fixture left on the station and rebirthed to the MB2 pallet in the aft end of the payload bay. A second node is attached to the node from the first flight. A truss berthing ring is added for subsequent berthing to the truss. The lower RCS module and its supporting structure are then relocated to the port side of the transverse boom, symmetrically opposite the other RCS module. The second alpha joint is assembled by the EVA astronauts with retrieval and positioning assistance from the RMS and FTS, as on the first assembly flight. The remainder of Flight 2 truss and solar array system are added, completing the second station assembly flight. In Flight MB3, the Mobile Servicing Center, or MSC, including the first station-based manipulator arm, are installed. A central radiator system, consisting of a rotary joint, pump package, fluid lines, mast, heat exchanger, and fins, provide active thermal control to the station after this flight. A TDRS antenna is added on this flight as well. With sufficient resources to support them, user payloads are accommodated on the station on Flight MB3. An airlock is then attached to the nodes, and another central radiator system is added to the other side of the transverse boom, completing this assembly flight. The hyperbaric airlock is added to the module pattern to support entry to the modules delivered on the next flight. Two berthing adapters will allow attachment of the docking module to the module pattern for IVA access. The second station-based RMS, installed on the Stinger, will help maneuver station components in this area. Additional U.S. attached payloads are accommodated on the station on Flight MB4. Flight MB5 delivers and installs the first pressurized module, the U.S. laboratory module, to the space station, completing the man-tended station configuration. The U.S. habitation module is joined to the station in Flight MB6. The arrival of logistics modules and crew, after the nodes and cupolas are added, marked the achievement of a permanently manned station configuration. The station can support 2 logistics modules at a time, which enables switching logistics modules on a single flight. One assembly flight supports the addition of 2 solar dynamic power modules and the sections of transverse boom truss that support them. The remaining MB assembly flights complete the space station, including the GEM and ESA modules and U.S. and international payloads.